In this session, we will be discussing about handling deadlocks. So, whenever deadlocks are formed, then how can we handle them? So, last session we have seen four conditions to form a deadlock, which is nothing but mutual exclusion, and the other one is no preemption, and the other one is hold and wait, and the other one is circular wait. If at all deadlocks are formed, if at all deadlocks are formed by satisfying these conditions, then how are we going to handle them? So the handling is two categories, pessimistic and optimistic. In pessimistic, you can do directly deadlock prevention and avoidance. That means they are going to satisfy before deadlock occurs. Optimistic is after deadlock occurs. It is nothing but deadlock first detect and recovery and deadlock ignorance using ostrich. So deadlock prevention schemes. So we want to see that the opposite nature of four characteristics of deadlock. One is mutual exclusion. So we want to dissatisfy. No preemption. We want to dissatisfy. Hold and wait. We want to dissatisfy. Circular wait also need to dissatisfy. So we are learning deadlock prevention schemes by dissatisfying four characteristics of deadlock. First one is that prevent mutual exclusion. How can you do prevention mutual exclusion? By saying a concept called sharing. So when you say that there is a resource is available, that resource, if I able to share to different processes, therefore what happened? The processes are no need to under waiting stages because the resource is under which mode? Shared mode. Whenever resource is shared mode, it is giving to process X as well as it is giving to process Y. Then there is no concept of waiting age, which leads to further indefinite starvation among two or multiple number of processes. But sharing of the resource is not always possible. So we are trying to dissatisfy mutual exclusion property such a way that resource can be shared. So when resource shared, then there is no chance of deadlock. But it is not always true. Mutual exclusion can be dissatisfied by saying that resource can be shared, but only certain resources only can be shared. So what resources can be shared? So simple example, we see that resources can be shared among processors, which is nothing but files. Files can be shared, memory can be shared, and the CPU, because only one process you need to run, so CPU can't be shared. So in such cases, some resources can be shared and some resources cannot be shared. So in this case, printer cannot be shared, but files can be shared. So that is what is the meaning of prevention of mutual exclusion. So a file by name called DB, that is sharing among two processes. And a printer you can't share among multiple processes because it follows a serial nature concept. One process after that another process should be executed. The rest of the processes who are there, they are supposed to be in the queue. They are supposed to be in the queue. The second one is that prevention of hold and wait. So what is the hold and wait concept? We know. So there is a resource X and there is a process 1 and there is a process 2. Resource X is given to process 1 it is holding. That indicates that P1 holds resource R1 and it is requesting for Ry, so that Ry is already given to P2. In this case, what happened? The P1 is going to be under waiting. So this is what is the meaning of hold and wait. This is one of the characteristics to form the deadlock. So what we do here, we want to see that the dissatisfying of this condition by saying only one rule. What is the rule? Either you get all the resources, whatever you want to execute successfully, or release all the resources. Only two terms are there here. One is get all the resources, get all the resources required by process to before begin. This is before begin only. What are how many resources you want, like resource X, resource Y, resource 1, resource 2. As you are feeling that I want to see that these are the resources needed for successful completion of execution, then you do it. If any of the resource you unable to get, then release all the resources, because anyhow you can't run unless and until all are required. So it is breaking the principle of hold and wait. How it is breaking? You are holding a resource X and waiting for Ry, as Ry is not available in this case. As Ry is unavailable in this case, that's why your strategy becomes waiting. So what this principle is saying, to dissatisfy hold and wait, if you are unable to acquire both the resource, then release it. So here what happened? P1 release. P1 released Rx. When Rx is released, then Rx can be given to P2 because P2 is asking. Otherwise, if you look at the corner of P2, P2 is waiting. So don't wait. You release Ry, therefore that can be given to P1. So that is what. Either you get all the resources for successful execution. If you are unable to acquire any one of the resource, then release all the resources. Then release all the resources. Then when you release all the resources, then your edges are broken. Edges are removed. Then there is no concept of hold and wait. So that is the meaning of prevention of hold and wait. A process should not hold resources while waiting for others. A process requests all required resources before execution starts. If for any process, if a resource is unavailable, the process waits without holding any resources. Then in such case, low resource utilization, possible concept of starvation. So, third characteristics we want to dissatisfy preemption. No preemption, so we want to write in the form of preemption to dissatisfy no preemption. So, preempt the resource. The resource can be forcefully taken from a process. If a process holding resource requests another unavailable resource, it's currently held, resources are released and allocated later. P1 holds a resource R1. What does it mean by that? There is a resource R1 which is held by process P1. And P1 requests for R2. P1 requests for R2. And R2 unavailable in this case. R2 is unavailable. Then R1 is taken back from P1. R1 is taken back from P1. Next, circular wait. So how can you say that there is a circular wait happen? By seeing a resource allocation graph. There is a resource R1 which is given to process X, and process X is requesting for resource R2, and R2 is unavailable in this case because it's already allocated to PY, and PY needs one instance of R1, but R1 is unavailable. RY is unavailable. In this case, Py, request edge becomes a waiting edge. In this case, Px, request edge becomes a waiting edge. So what happened? R1 is given to Px and Px is requesting for R2, but R2 given to Py and Py is waiting for R1. So it leads to circular wait. Then how are you going to prevent it? There is a small condition we want to impose. What is the condition we want to impose? Write the resource numbers neatly and increase the resource numbers either linearly, ascending order, or descending order. Resource numbers must be given and resource numbers must be either increased or decreased. Either the principle is supposed to follow, not impose both the principles. If I am going in increasing manner, you give the numbers, next numbers to resource. Or if you are coming with a higher number to lower number, decrease the number. Don't follow it together. Either that you need to follow. So there are two resources. One I have given to P1. Now P1 acquired resource R1 and R2 is given to P2. Resource numbers are correctly mentioned because first the R1 and next number is R2, next number is R3. Likewise, you need to go in incremental manner, either decreasing or increasing. We don't mind. Now, so we are trying to see that circular wait to be broken. So P1 is requesting for R2. Is it possible? So we want to cross verify small condition. What is the condition? P1 holds which resource? Resource R1. This is the first point. Second point, P1 request for resource R2. So we want to cross check. What is that? Your earlier number is R1. Now you're asking a request for R2. So your R2 number is greater than R1. Then if this condition is satisfied, this is as far as P1 concerned. So this condition is satisfied because 2 is greater than 1. Then if at all R2 is freely available, you allocate it. Otherwise, ask P1 to wait or allocate if freely available. Wait if not free. And third one, let us see in other side. P2 holds resource R2 and P2 is requesting for R1. P2 request for resource R1. This request is validated before wait or allocate. So it is validating. How it is validating for P2? It is checking that. So R1 which I am requesting, this first one is request only. Second one is already allocated. So R1 is not greater than R2. Therefore, P2 request will be denied. So when P2 request is denied, even he is try to ask that I want to have the request to R1, not possible because your earlier number you acquired is 2, but you are asking to acquire lesser number to that. Then immediately your request will be denied. When your request is denied, then there is no circular wait in this case. P1 can be under waiting because P1 earlier resource number is R1 and it is requesting for R2, it is allowed. But P2 earlier holding resource R2 and requesting for lesser number, it is not possible. So there is no circular wait. So that is the meaning. If you are going in increment manner, you check greater. If you are going in a decrement manner, you check lesser. So that's what prevention of circular weight. Eliminate circular chains of weighting. Assign unique number to each resource type. Process must resources only in increasing order. R1 is equal to 1, 2, and 3. We need to cross verify P1 should request for R1 and R2 and R3. P1 first hold R3, it shouldn't request for R1 because R1 number is lesser than to R3. So this is how you can impose prevention schemes for the deadlock at any stage they are going to be prevented. How? Mutual exclusion to dissatisfy, no preemption to dissatisfy, hold and wait to dissatisfy, then circular weight to dissatisfy. So these are how circular weight, preemption, and hold and wait can be dissatisfied.